And it's my really great pleasure to welcome you all. Thank you for coming over. And the first person I would just want to start with an opening statement would be Mark from the Swiss Institute of Bioinformatics. We both are colleagues. Thank you very much for coming over, Mark. And what is your story?
Okay, well, first of all, thank you very much to Leila and the organizers for this opportunity to be part of this initiative. And I feel a bit humbled to be here because, honestly, sometimes I don't feel like an expert because in this area, because I'm learning every day, and I think this is one of the things when I think I know how to do something in terms of this, data sharing and privacy and learning from experience, another issue comes up that I haven't seen before, and I think Marcel really explained this really well, that things that you don't expect, that the problems come from where you don't expect. So where I come from, my story in this area is from a few years ago I think it was in 2016, where we started off to be involved in a public-private partnership. It was called, the project was called Rhapsody. It's now finished, and this is a project on type 2 diabetes. And the idea at the start of the project, and this was even in the call text for the start of this project, was that we wanted to benefit from a lot of different clinical cohort data spread across Europe. And we didn't want to get into the problem of having to do data transfer agreements, having to have agreements to analyze data and then somehow merge the results of these data sets. We wanted to do this in one federated system and be able to do federated analysis. So this was the goal at the start of the project, and the idea at the start of the project, when I first came into the project, most of the people said that they didn't believe that this was going to be possible because people have their own ways of doing things. And before this moment, people in the community, in this type 2 diabetes community, were collaborating together, and they were sharing ideas, but they were doing their own analysis on data, and they were then working together with colleagues who were replicating the same analysis, and then they were putting the metadata together. But of course, the problem with this, as we know, is that the reproducibility here goes out of the window. We have this problem of reproducibility and the fact that errors get made, and we don't know exactly what we're comparing. So the first thing in the project was to harmonize and structure the data in these data sets. And we had, in the end, 12 data sets that we did, and these were clinical prospective cohorts. And really, this was the biggest challenge, I would say, that we came across, was having to work together with people at a distance to make their data, get their data extracted from their local sources in many different formats, and harmonize this together, and then put this together into a system where we could actually access this data from at a distance. And this was like 80 or 90% of the work we did. And just to give an example of the type of thing that I learned, and this was something that I had no really idea about the complexity of this task before we started, was we were working together with one particular cohort, and the data manager, we were in close contact with the data manager, and she said to me, I'm starting to extract the data. I said, this is really good. We have the list of variables we're going to extract, and then weeks weeks went past, and I came back to her, and we had another meeting. We said, how are you getting on with the data extraction? Oh yeah, it's going okay. I'm still extracting the data and cleaning it. And I said, okay. And then a few months passed, and then I still came back, and she was saying, I'm still extracting the data and cleaning it. At some point, I decided to go over there. And I made the trip, and it was actually a part of another meeting, so that was fine. Made the trip over there, and then she showed me what she was trying to do. And it's only when I saw really what she was trying to do that I understood the complexity in actually getting data out and really managing it and making it clean and reformatting it. She had a data set which was 20 years old, and it had over 100 different sub-studies, which are all in different formats, all in one big database. And my understanding of a database was you have a set of tables, and you can somehow query them and get the data out. But this is not the case. The data were in this, they were in like 100 different databases. And so this is just an example of the complexity of this. And so the biggest challenge that I found was actually this data extraction and harmonization. Another challenge, I don't know how much time I've got left, but is that okay? Another challenge was the the fact that, that when you started talking about a federated analysis system or some way to access and analyze data at a distance, changes the way that people are working. People are used to working in the way where they control the data. They have their own data set, and then they know someone who has another data set, and they collaborate with them, and they do their analysis. They don't themselves do the analysis, but they collaborate in that way. And I think this way of letting someone else analyze your data, which sits in your institution, is a real challenge, and it means that you have to think about, change the way that people actually are doing the analysis. And it was a challenge to get that message across, and the only way to do that, we found, was to actually get someone who was our, like, the champion, a champion analyst who really liked the idea and wanted to do it, to show people how it works, to write the analysis scripts and say, hey, look, I have analyze your data on your cohort, and now I'm sharing you the result. Can you go back and check? And I think this is really the key thing, that you have to have champions on each of these. You can't just let someone access the data and do analysis and not be in collaboration with the people who are actually sitting on the data and controlling the data. So that's all I wanted to say.
That's fantastic. Thank you very much for this introduction, Mark. Real pleasure. And the next person I want to introduce is David Manse. David is a successful entrepreneur, having run several companies, but David is also incredibly successful to be part of large consortiums on the European level. So there is a really number of projects that he's been involved in the past. And David, how did you end up in the field, and what are the pain points? What are the lucky moments? Can you tell us?
It's a pretty long story. I will make it short. So first of all, thank you very much for inviting me. I'm very pleased to be here today and share experiences and learn from all of you, more in my field especially. So I started the journey a couple of years. It was back in 2002 when I was doing my PhD at CERN, the European Organization for Nuclear Research. And basically, at that time, CERN was looking to transfer an important asset of technology, which was the grid computing, to society, and it was looking to apply grid to the biomedical research area. So we started deploying that solution and adapting that solution so to make it possible for the first time for hospitals and research centers across Europe to start sharing personal data and do distributed analysis in different types of pathologies. And so what was very interesting at that time, it was the premises of applying the grid to other areas than high energy physics. And very quickly we ended up in the struggle with protecting data, because the hospitals were reluctant to get the data out of their information systems, transferring data over the internet and so on. So we've been facing a number of issues with learning actually about the typology of data. So what the data is about, what can you get from the data, what can you guess from the data from an individual standpoint. So we've been, as you said, working in a number of European consortia which were looking to establish those networks of research where data was to be shared between the centers. And over time, we've seen the issue of privacy growing and evolving. At the beginning, it was mainly a security concern. People were not even making a difference between security and privacy. And then it became something specific because of the data, because of what you can do with the data and the typology of data. And so over time, I had the opportunity to go to different hospitals in Europe. I've been installing more than a dozen of them with our solutions, so concretely putting the servers in the racks, tying the network and configuring the computers and getting access to the data. And clearly over a time span of almost 2 decades, it's been very difficult to make people understand what data is about and the risks associated with personal data. And so I ended up in a number of situations where I could access very personal information, whereas I was not theoretically authorized to. I have a number of examples like this. Like, for instance, I was once in a famous hospital in Rome, in Italy, looking to get some samples so to understand what kind of data protection we could set up. And the physician was like, oh, well, no problem, I will give you an extract and I will anonymize it and so on. So he gave me a USB stick. And basically, I got the entire database of kids of the hospital with everything, absolutely. So I deleted it. But to give you the understanding is that the people do not really understand the risks, do not see what the problems are, and do not even know how to protect the data efficiently. I have other examples like sharing PDF scans with physicians, where physicians were just putting frames to blank some areas in the scan, so not to see the names and other types of information, but where they were not flattening the PDF. So an educated engineer could just open the PDF with a good writer and just remove the boxes and see everything. And I have dozens of examples like this. The problem is that we are not educated about data privacy. Not sufficiently, even today. Today we are getting sensitized to it because we see every day data leaks in the news from various large American, essentially, platforms, but also from some of our national health services. I can give you some examples in France, very recent actually, about the COVID. And so people just don't do what they should be doing. They do not have any data hygiene. So they put data over the cloud. They don't even know which cloud it is, where it is going, who may have access to it. And they don't even understand that at the end of the day, the problem is not them, the person specifically. The problem is the profiling we can do over a population and the categorization of psychological profiles, because this is where the value is, because behind that, you can sell services, you can sell advertisement, but you can also try and manipulate people. And that is what is happening on major social networks to date. So that's the very problem. And so I think that from my experience, what I've been struggling with is the lack of education around data privacy, and that is one subject I'll be looking to discuss here.
Great. Thank you very much, David. It's a really good intro. Next would be Johan on my list, and I know that you prepared a couple of slides to visualize. Okay, I think we're struggling with the slides, but if you're happy, no Johan, Johan traveled from the Netherlands, the country that is pretty advanced when it comes to the development of the methodologies of privacy-preserved and distributed computing. But tell us, what is it like today? What are the projects, what are the challenges, and what is your, how did you end up in the field?
Well, slides are there as well. Right on time. Yeah, so as the main pitch is actually, it's not the technical development which is the problem, developing these infrastructures. It's more the surroundings in which they are functioning and in which they are working. So if you can click to the next one. So indeed, we started, let's say, 10 years ago, roughly, on this. And like Basel here, it's Maastricht is a region with Belgium, Germany, maybe Luxembourg as well. So it's also that you need to travel often over these borders, and then it quickly becomes a problem in terms of sharing, especially before GDPR regulation. So we started on this, let's say, 10 years ago, and with 5 centers in the region, and what we started is, okay, let's send people there, harmonize the data, do the work, talk to the people in the hospitals, what we want to install, what we want to run, what we want to do, which roughly takes a 3 months period to send someone over. Also that they see some pressure because someone's here, we need to do that in that time period, all these kind of things. And eventually we got that up and running and working. That spread from 5 centers to, let's say, 25 now all over the world in the field of radiotherapy mostly. Can you go to the next one? But yeah, the federated analytics, as you can call it as well, doesn't solve all the problems, right? it basically means that the problem of interoperability and semantics even becomes more prominent, because you can't see the data, so you have to trust on some definitions, which means, well, you can do it without, but then it's going to be a lot harder. So it doesn't solve that problem. The second one is that, well, it doesn't solve the problem of bias in data, of course. It's the same data what you would have centralized, but now distributed. So you need to do all the same things as what you would do in a centralized setting, basically. Also the same analysis on the data as if you would do in a centralized setting. And the third one is maybe more on the administrative side, but what we learned also is that if you do this kind of federated analysis, well, it says data sharing, but it basically means that you still are forming consortiums and also still defining who can do what on the data, who is contributor of the data, who can do the analysis, who may publish on the data, all these kind of things. So the whole, let's say, data transfer agreement, what you usually put in there is, yes, what you do with the data, but also all these other things. And still all these other things is still what you need to arrange. So you can't dismiss that at once, basically. Well, where we are now, so that's more on the next slide, is, well, we can skip this one, I think. I'm not sure. Oh, can you go ahead one more, probably? Yeah, so where we are now is that what we recently did is on radiotherapy and lung cancer patients on several continents, so in North America, Europe, Asia, and also Australia, with, I believe, 8 centers, pooling 2,000, more than 2,000 lung cancer patients, and building a prediction model on that. And, well, does that mean that that process took very long? If you can click the button. Well, actually, no, not in this case. I'm not sure if it's showing up. Yes, because if you see the timeline for this project, it's roughly a year for conceiving the idea to actually getting the manuscript submitted. And if you look then from the second pool on the left, so April, that was where we were actually starting to discuss with participants, hey, do you want to contribute? And then from June, then we actually started to formally invite them, and then in September start the analysis. So does it mean that it's a long setup process? No, not always, but these were also centers which participated in previous execution, previous runs. So they exactly know what's coming, which formats, which contracts are coming, which legal requirements are coming, all these kind of things. And then that process can be relatively quick, actually. But that means that you have already some kind of partnership and collaboration with all these people. Then we can go to the next one. Well, then the question is, we're doing this with our own open source infrastructure, what we build ourselves, but there are many out of there as well. Melody, for example, Medco, Data Shield, you can name all of them, but also the bigger partners like Google with a federated TensorFlow, Microsoft, you name it, Dell EMC, HP. So in that sense, the question also becomes a little bit, do we want to develop our own infrastructures, or should we just more look, can we work with all these infrastructures, and what are the rules of operating these things, right? Instead of focusing on building the next technical thing as well. And that's basically, on the next slide, more at the end of it, because if you want to run such a project, you need 3 things. It's first project management. The second is that you need to get the hospitals on board, so every data provider, which means different expertise within every data provider, every hospital. Project lead, legal support, domain experts, IT experts, they all need to contribute to get that working. And then afterwards, maybe you also need people as a third, you need them to write the analysis. So if you can, yeah. But the major obstacle is actually in the middle. If you can click on it, that's at every hospital, you need all these people in here. And that's the major obstacle, as Mark said already as well. So what we've been trying to do now more and more is, if you click on it, the problem is, if you would do this for academic hospitals, we'll find they have the resources maybe to pull this off. But if you go to first-line healthcare, for example, GP practices, which are maybe their own employed or own companies, let's say, well, do they need to think about how they should govern all of that in a federated learning infrastructure, or should someone do that for them? So therefore, in the Netherlands, as a consortium called Personal Health Train, we're trying for different projects with different IT backgrounds and different IT systems in the background, we're trying to come up with more standardized descriptions of what a federated analytics does and what it means actually, but also then a trust framework. So what are the roles, responsibilities for there, what every hospital or institute should do, and how would that work together? And then the last bullet, because, well, it's also a business model. Because now you're sending the analysis over to the hospital, which means the hospital needs to invest also in compute power and these kind of things, if it becomes a large data set or deep learning or these kind of things. So how do you make that business model also working, that all of these things can work actually? So that's more or less my pitch, that it's not more the technical side of it, but it's more getting to how do we operationalize on it and also set some governance frameworks in there.
Thank you very much, Johan. What a great overview. And my absolute pleasure to introduce Ansgar here. Ansgar is based at Novartis, and Novartis with a few other pharma companies are involved in a large, again, consortium called Melody. And for me, that one is absolutely mind-blowing, because we're often concerned about the privacy of patients and such, and this is what we want to protect and to preserve, to make sure that the information is not leaked out to third parties that might be using it with harm. But the project that Ansgar is involved and is going to be talking about today has got nothing to do with patient data at all. It is about chemoinformatics data, about the data that the issue is the intellectual property of a pharma company. So it's just the basic assay results, IC50s, structures of the compounds. This is where the concern is. And how can pharma benefit from each other together, collectively as a knowledge, without actually disclosing those data to others? So many things are stripped off there, but there are still quite a few challenges when it comes to the project. And Ansgar, please tell us more about it.
Yes, thanks for the introduction. As you have already said, there is 10 pharma companies involved who are kind of the data owners and bring their data in. And then we have that counterpart of the consortium from startups led by Hokkien, but also with academic machine learning experts, because this is not only, as you will hear, a platform type of thing. So what are we trying to do? Next one, please. So at the beginning, Onset Pharma had already the idea, instead of building a machine learning model for one assay at a time, for the hundreds to thousands of assays, that it is beneficial to do a multitask model with many assays at the same time. A lot of pharma partners in that consortium had that individual experience, but now the quest is kind of say, can we go from large-scale multitasking to massive-scale multitasking and just putting the task of 10 pharma companies together? That would be then 40,000 assays. And of course, as this data, the small molecule assay data, is one of the foundations of corporate IP, you cannot just give that to a central location, even if there are no legal privacy right limitations for you to do that, because there is not that level of trust to one central broker to host that data. So it needed to be a federated and privacy-preserving solution, privacy this time in the IP. Next one. So my role of this in this consortium was to orchestrate actually the standardization of the data for the federated learning among the pharma partners, and we actually had to split this up and kind of say, now there is in kind of what each pharma partner had to do on their own is a more or less a raw extract of their data warehouse into a standardized file format, and then we built a standard shared piece of code which actually did a lot of the sanity checking and standardization on top, and where we basically everything we could agree on that it has to be happen on every data set was kind of put into that code, which is kind of also open source, and every partner could have a look into what that does and run that on their data. With that, we were then ready to put the data into the machine learning in this federated setup, where each of the pharma partners would operate a compute node which would host a copy of the machine learning network, and then through a secure aggregation protocol, the network is trained, whereas the weights are securely aggregated and redistributed to the pharma partners. And now, of course, there is, if you kind of say each pharma partner operates a compute node because it wants to be in control of the data and in control of the computer. That means also in turn, of course, each pharma partner has to operate a computer, has to have the expert knowledge to do this kind of operation, because otherwise you cannot delegate this, right? As you cannot delegate the data preparation. And of course, as you also cannot delegate the detailed analysis, and also there we are trying to work on, at least for a high-level aggregation on the open source package which we are sharing among the partners. So that is basically the setup we are talking about. I think we can possibly skip the next slide, which is more on the technical architecture. I think there have been also a presentation here, and we are now at the conference already, and now we basically have done the second federated run. So this is in this consortium we had kind of set up to make 3 federated runs, set up the infrastructure for each run individually and dismantle it afterwards, because after the run the pharma partners can take the model of their task home and do with that whatever they want. So we are at the second federated run. There we could see that there is through the bank success, but it's still heterogeneously distributed. There are some assay types which work better. These are these which are labeled ADME, which are kind of the pharmacokinetics and PhysChem assays, where you would also assume that a lot of pharma partners run very similar things. And then there are other assays where we kind of still have a harder time to demonstrate success, even though some of the assays, the safety panel assays, should be still somewhat similar between the partners. And then, of course, also what you see here is that is one of the challenge. Not all pharma partners, so they tend to benefit equally. And now the challenge is, which we will have to master for the 3rd year, to make sure that everyone benefits, because everyone who brings the data in wants to see an improvement on their model tasks.
Fantastic. Thank you very much, Ansgar. Well,
I mean, just that maybe kind of as the last thing, of course, we want to also have post-project sustainability, and the intention is to keep that running as a fee-for-service, then also with the possibility to onboard other pharma partners.
Great, thank you very much. I think one of the first questions that really just is still sitting on my mind is when I started learning more about this, I realized that there seems to be no uniform definition of privacy as such. So we're talking about privacy preservation and somehow measuring how well or badly it's done, but I couldn't find a single definition. Could I ask each of you, starting with you, Ansgar, what is privacy to you as an individual and as a professional? How do you understand it?
Okay, let's start with the professional as from the point of Melody. There it's very easy. It's intellectual property, right? We need to make sure that each of the pharma partners retains the intellectual property and to get IP on the drugs they produce, and we cannot compromise that. I mean, as a person, of course, I'm also concerned about privacy and to see what I'm doing, where I wander around, and I want to kind of not make that generally known to everyone. And I am always glad if some things are reasonably decentralized, but of course I tend to be also a lazy person at some point, and sometimes that means I'm probably going to use one of these services which gadget providers deliver us just because it helps me getting there, and maybe not asking kind of if I'm making a timetable request to the SPB webpage, what kind of SPB might learn from me by doing that.
Great. Mark, what is about you? What do you have sleepless nights about when it comes to privacy? And then when you switch your hats as a professional, how do you see it? What is it?
Well, I think for me, privacy is well, anything to do with me as a person, and that could identify me and be potentially not a good thing if that I don't necessarily want people to know about. So I mean, obviously, I don't want my address to be available to everyone, but to many people, I want to decide who I give my data to. That's basically the end. I want to be able to control it, and I think that also from a professional point of view, when coming back to this project that I mentioned before, I mean, one of the things which in terms of privacy that we shouldn't forget as well is that the people who invest a lot of time and effort in generating data and thinking about problems, scientific problems, and how we can do this, they've invested a lot of time and effort, and they want to keep that data private until they're ready to share it as well. And I think that there's a counter argument which says this is public money. You should share it. You're using public money to generate this data, therefore you should share it. But the reality is that this is still considered private by them, and they don't want competitors to get hold of this. So I think that from an academic perspective, I think that's often what happens, and this issue of privacy is often used as well as, oh, we can't share it because the patient-informed consent doesn't allow it. But actually it probably does, because the patient-informed consent often now says that the data can be used and the patient will say themselves they want their data to be used for research purposes. They might not want it to be accessible to every company on the planet, but they definitely want it to be used for research. So I think that there is this other level of control over your professional life and your career.
Yeah, great. So it is a concern of being able to control what is shared and with whom, but at the same time is often used as excuse to stop.
And it's right, yeah.
Okay, great. Johan, what do you think about this?
Yeah, so it's always also a hard question, to be honest. But let's say privacy, to me personally, I would say, is that I can only share the information with people, or some information with people I want to share that with, right? But from a work perspective, and I think that's also more in some kind of the legal documents, if I look at the Netherlands, it's more about that you don't have a reasonable method to link many things together that you can identify someone. And the question is, what's reasonable then, right? And that's a little bit the hard part in there. The other remark from a professional perspective is that if you look at privacy, we have to discern privacy and security a little bit better. Because sometimes privacy preserving, if we then go into the share without sharing, is sometimes also more security methods, but doesn't mean directly that also is privacy itself. And therefore, if you look at the different methods, different definitions and these kind of things, well, if you set your own definition, indeed, then you can also claim it privacy preserving. But yeah, to whom? Also within these infrastructures, but maybe we'll come back to that later.
Great. And David, what are your thoughts? What is it for you as a person and as a professional?
So, first of all, for me as a person, I think that there is a flow in privacy, at least in the way we are practicing and understanding it in Europe. The first thing in Europe is that we don't have the ownership over our own data. We just have the right to use and exploit our data to decide. We have new rights with GDPR, like rights to access, erase, modify, right to be forgotten in some contexts, right to have data portability in case we want to move from a professional to another. But we have essentially, I would say, access and usage rights over our own data. We don't own our data. That's the first flow that I think we have behind privacy. Because in privacy, privacy relates to something private. And I do not have private ownership of my data. That's the first thing. The second is, I think that we are mixing intimacy and privacy. Privacy, I would say, is a rather regular term that we all use every day. That's more related with the use of data in a professional context. And I think that we have lost the importance of intimacy. There are things about our lives we don't want to share. And this must be protected. And I'm not sure that as of today, the border between intimacy and professional privacy, so to speak, is really well established. So I think that the most important aspect behind this is what we call informational self-determination, which relates with the fact of being under control over the data we are sharing for a given processing purpose with some individuals or entities. And so to me, privacy is a subtle mix between intimacy and professional privacy, and that implies a real empowerment of data subjects, so people. which is, I think, today the most important problem. I think it's not solved because when you have a look at the information system in all sectors around, they have been developed in a business-specific way. So their data models, their logics, their business logics is business-orientated. It's not centered onto the individual. So it's very difficult for them today to switch to a GDPR world where they can apply your rights strictly over the data. So I think that this is the core problem, informational self-determination.
Wonderful. If I stay with you, David, and then I would want to hear from Mark as well. You mentioned the GDPR world. Of course, we had the legal framework and the system and regulations before the GDPR, but since it was introduced, do you think it is an asset for data analytics or a hurdle? Do we benefit from it, or it makes our life difficult?
So GDPR was introduced in May 2018. I think today there is not a single business in the world that is able to abide to GDPR fully, because as much as it is absolutely indispensable, because we are in a world where technology is moving so fast that we don't have the time to think about the ethics, to think about the risks and the consequences, that we have to have legal barriers and protections, just like a security stop button on a machine. And I think GDPR is providing some of the answers to have this very, I would say, very minimal protection. So to me, GDPR was and still is absolutely indispensable. But at the same time, as we are in a world that has a significant legacy in terms of IT, information system developments, we have a long way still to go. So to make all these IT technologies progressively abide to GDPR and make the necessary things available for the individual rights and all the technical measures of GDPR apply. So it can be perceived as a hurdle because when you are an information system head, heading a department of information system, you have to set up a roadmap and review all of your information systems, processes, and so on. But it is absolutely indispensable. The other thing, and I will conclude with that, is that GDPR has I would say, two major sides. And there is one that is organizational. That's more about processes, about roles and responsibilities throughout the enterprise. And that is, I think, the one that was the easiest to tackle for businesses in Europe. And I think that this has been mostly done because this is the first and foremost thing you have to address in case of a legal complaint and so on. And that is the easiest because it's just a set of documents, a set of processes, a set of peoples and responsibilities to set up. The other is a bunch of technical measures that you should be applying upon your information system, data flows, and so on. I think this one is more difficult because you have to understand the data typology, sensitivity. You have to be clear about processing purposes. You have to have a strategy whether you just process the data for a given purpose or if you want in the future to do some secondary usages. So it's a very intimately related question to the strategy of the enterprise. So it's not so easy to answer. And I think it's going to take at least another 5 to 10 years unless businesses start really addressing GDPR in full.
Okay, so in a way it stimulates understanding and adjusting to these fast developing technologies that, as you said, are unstoppable anymore. We cannot just press the button. Mark, what do you think about this? The legal framework and the world of the GDPR, is it help or?
Yeah, well, first of all, I think it's really necessary, and I think one thing that I noticed is that before GDPR, and we were talking about GDPR, but before it came in, I would not say regularly, but I had received like clinical data sets by email, unencrypted, and then what do you do with that? I mean, you know that it's wrong, but so you delete it and everything, but do you delete all the copies? Is it deleted from your backup? I don't know. Anyway, but I think that crystallizes the problem that still exists, but there's not a, and I think this was mentioned earlier, that there's not a, people say, oh yeah, it'll be all right, we can send it, no one's going to leak it. But the GDPR says you cannot do that. You have to abide by some rules, and I think the problem and the what a lot of time that I see is taken up by our legal department at the SIB at least is in trying to deal with the interpretations of the GDPR. And I think this is something where if each country has their own interpretation of GDPR, and I know for a fact, I think that Germany has a different interpretation, and it's more than, for example, Switzerland or I mean, Switzerland is not in the EU, but it's aligning with GDPR. So I think that if each country has its own different interpretation, and legal departments have to interpret it in different ways, in some way it needs to be adapted to make it clearer or at least more specific. And I think that is something that is maybe a problem and is creating a lot of headaches. Yeah. Great.
Well, thank you. Good points. Now, if I switch to Ansgar and your fantastic project, I'm a real fan of Melody project. The privacy-preserving methodologies and techniques, assuming that all the data are fantastic, ready for the input, harmonized, semantically interoperable, how would we know that the project is successful and running? The privacy-preserving distributed computing and machine learning is actually doing any good to you as a parties? What do you think would be the criteria?
I mean, the first criteria which you can directly measure is, of course, all the models gather in their predictive power. You can do that with holder test sets, so that's kind of the good practice of machine learning, and of course you do this. But in the end, of course, and to turn that into business value, we have to employ these models. So that means we have to give the models and then in an interface back to a chemist who wants to make a compound so that he can make the predictions to guide his decisions. And of course now, as I said, the companies may have hundreds to thousands of assays. You may also think that kind of how you return predictions like that to a chemist who wants probably only to see some assays. There is an integration work to be done in the corporate infrastructure of the tools the chemists use, which is necessary to turn that into business value, which means you don't avoid making compounds which have a low success chance, or you avoid sending compounds to an expensive assay where you could perhaps, with some certainty, anticipated the outcome. That, of course, makes things faster and less costly. But, of course, that will take quite some time after the closure of Melody until we see these kind of changes.
Great. Thank you very much, Ansgar. And Johan, you mentioned already that the definition of success might depend on the definition of privacy. And you obviously published numerous papers already. What do you think would be the objective criteria if you would disconnect from the definition of the privacy itself?
That's a good one. First of all, the question, as this morning also in the keynote presentation, do you need something federated or centralized, right? What's allowed, what can you do? Because if you look at privacy, we see, let's say, such federated learning infrastructures, we see it more or less as, well, the patient privacy is not there anymore, but we also now see with more advanced techniques that maybe sometimes some information, let's say, is sent to a central location where it's being aggregated, right? And if the numbers get small or if the information becomes too detailed, that central location can still have something which can be identifying. So therefore, the definition of, let's say, what is privacy, I would say to whom and who do you trust in there, right? It's not that we can get a 100% privacy in there, but it's more or less what do we accept in there. Yeah.
Great, thank you. I would love to hear from the audience in just a few minutes, because I'm sure you will have some questions or some comments or some thoughts from our panelists. But before I do that, do you have any questions to each other? Is there anything you wanted to clarify, given the adjacent experiences and complementary expertise that you have? Ansgar, please.
Well, I assume also when you have these federated architectures that you want to do machine learning, has the concern about kind of what can you get out of the model once created, how much can you reverse engineer data, which is the model has learned, has that been kind of a concern?
Yeah, we're actually now redoing that 20K lung cancer patient set, but not on clinical data, let's say, or the more structured data, but on, let's say, the medical imaging. And then you enter, let's say, the whole deep learning field with neural networks, and they get very well detailed in their network to the point that we are not, let's say, ourselves looking anymore at all the individual nodes in the network, how they operate, but there are proofs out there that in some cases you can reverse engineer what the source image would have looked like. Again, it's then a numbers game, more or less, about how many patients are coming from every hospital if you're aggregating these kind of things. But it's definitely a concern which is playing in there, and therefore the question is, up to what point in the infrastructure, where do you put trust in? And where do you say, okay, it's fine that that's not 100%, let's say, privacy preserving, but at least the outcome, what the researcher gets back, is 100% privacy preserving.
Anybody else would like to add to that, David?
I think I wanted to react actually when you were describing your federated learning architecture. I think that I was interested in the questions related with the with traceability and the overall the explicability of the models. I don't know if you had the opportunity in your project developments to think about exploiting the traceability coming from the model's execution and the analysis you distributedly executed to work on methodologies to come up with some models or approaches to better explain the results of the machine learning models that you could get out of your experiment.
Well, admittedly, neural networks tend to be pretty black box. Now, I think there are suitable chemical descriptors which kind of allow to reverse the embeddings, but then, of course, they come also at a risk that all these membership attacks probably become a lot more easier. That's why we have decided against maximizing the explainability of the model, because that would have come at an increased risk that these things might become reverse engineerable. And that's kind of not a question about what can you do today, right? Today we can maybe also, and we do actually in Melody, let some a reverse engineering specialist attack the model and see on a model built on that same architecture on public data and see what he can recover. But of course, that doesn't tell us anything about the capabilities 5-10 years down the road. Now, you could argue for pharma data, maybe, yes, for some of the data points, the data is not that hot anymore, but still I think our structural assets live in the company longer than that. So I think this is, I think, one of the questions where we are still also always kind of think of what's kind of the risk exposure through these models once they're in the world.
Mark, did you come across with this, how to avoid this reverse engineering or have robustness of the models?
Not really directly. We haven't actually been running a lot of federated learning, I would say. We're starting to do that. And I think that, this issue of black box and just, hoping that the algorithm will find you your result. I think this is a problem with any type of machine learning, whether it's federated or not. And so I don't think it's anything particular to federated learning, as far as I understand. It just makes the thing a little bit more complex. I mean, I have a sort of related question maybe to others. I mean, it's, we see, and especially here, I've seen many different companies now who have, fantastic solutions for federated learning, and it's all proprietary. And my question is, and there are also other open source initiatives which have been around for a long time, and my question always is, when I don't know exactly what you know, what's in the company's system, and maybe if I can get a white paper explaining that, but I will never be able to control that. And thinking about sustainability in the future, if we want our systems to be sustainable in the future, should we be focusing on open source and making it this type of technology as open source as possible, or should we be putting this in the hand of technology companies? Does anyone want to answer that one?
Does open source matter, Johan?
Can give it a try. So there are two sides of the coin here. Yes, open source makes it possible that people can see and what's happening in there, and that it's completely transparent. The other question is, then people can do in transparent open audit. That's okay. But it also means for companies that they're losing out on, let's say, then we're going more to the business opportunity to intellectual property. And then you enter the whole thing of, if my competitor can do it as well, why should I invest? So there's also, if we want to bring it out of the academic sphere to the companies, because to make it also sustainable from that perspective, there's also a balance to find. Maybe the ground layer of technology we should make open as an infrastructure, but what's being built on top, or maybe the trains what you're sending around, that might be something for the company, right? And then still, as a hospital or anyone who has data, you can decide, do I want to accept that one, or do I disregard that one because I don't trust it, for example? That also feels a little bit like pushing the problem a little bit forward and not solving it, but maybe that's an in-between for the moment.
Benoit, you are shaking your head. Can I just hear what you're thinking about this?
Oh yeah. Well, for me, open source is a must, yeah, for generating trust, but it's still not good enough, because you still have the risk that somebody will make a loophole, and you need really expert to dig down to check that it's really safe. So it's a must, but yeah. Yeah, and when it comes to property of companies, I would say yes, but you have to share. I mean, companies more and more sharing with others. I mean, they know that there's all kind of a field pre-competitive, where we better partners, and Melody is a good example of it. Yeah.
Great. Thank you very much for opening to the audience, and I think we have a question there.
Yeah, I would just like to make a comment on open source and the Hokkien experience. So we are the partners who are developing the solution in Melody. And actually, I would say 95% of the solution is open source, but not the last 5%. And I'd like to come back to the comment on Johan, which I think is the good one. For us, it's actually difficult to find a good positioning here, because if we make everything open source, then somehow we don't survive. And but we do want to make it open source because hospitals require it, because that's the new game. And we are here talking about a technology which is about communication between different entities. And there will be a unique standard. It's a winner-take-all situation where the open source will win in the end. At least that's our belief. So we are a bit stuck here, and we need some help somehow to figure out what's the good way to play in a way where things are open source, but at the same time we can build companies out of this, and not because we need funding to survive somehow. So I think it's a very good point, and I would love to find the best setup, and we are pretty much involved in this. But to be honest, it's a tough one.
Thank you. JP, would be great to hear from you.
Thanks a lot. So I'm Jean-Pierre Hubot from EPFL, so thanks for setting the panel. It's a great discussion. About the open source thing, so we have devoted a lot of reflections to this issue, and indeed there is the problem of the protection of the IP. Now, there is another dimension to it, which is, there's of course transparency, right, that is brought to some extent by open source, but there's another concern which is very high actually on the agenda of the end user, which is avoiding the vendor lock-in, right? And so a completely black box proprietary solution, in a way, is a blank check forever, right? So people really want to avoid this. So I think the future will be solutions that are mostly open source, as has been mentioned before, and with public APIs and with standardization, right? Yes. In order to avoid, let's say, this phenomenon of lock-in that actually can be a major roadblock to the adoption of these things, because end users will might perceive it as a kind of a trap.
Yeah.
Thank you.
No, I definitely agree. So the thing is, what I meant more is that by definition, the infrastructure should be open because you need to trust how things are getting in, because otherwise, well, hospitals would say, okay, application coming in, doing something on my data and sending something back to someone I don't know. Okay, that's by definition a virus, right? So you need to have, first of all, there some safeguards to know how the infrastructure works, that everything's okay and that everything works. The analysis on top, well, I don't think that we're going to reinvent the wheel on building all these, let's say, algorithms in a proprietary format. So I think indeed 95% of the analysis algorithms will be open as well. Then there's the last 5% of things where people don't want that. We had an example in the Netherlands. Well, I don't think it was a good example, but still, they said, well, we don't want that because we're a quality registry in the Netherlands. If we do that in a federated setting, then the hospital knows how we calculate our indicators and they're going to game the system. Well, okay, that's an approach you take. Not my favorite one, but for these situations, then you can build trains on top of that open infrastructure, maybe, where you keep them proprietary, but that's going to be only indeed the 5%, as the person in the back said as well. Yeah.
I think that what was just said about open source overall approach to essentially public goods and services is definitely the right way to go. But I think we may be missing one thing here, is that those companies, those businesses developing AI, the sources are even close to them when it comes to training models. The models they get from the AI, they have no clues how they were coded. I mean, it's a neural network's been loaded with data, synapses that have been growing and interconnecting various how do you say, neurons. So the point is that you have a black box. These companies offering AI services, they basically have black boxes that they don't even they cannot even provide the sources of. They can provide you with the parameters they used, the type of technologies they use. They can show you the models, but they cannot show you why the neural network's been reacting like this. So I think there is, additionally to what you just described, we have to have new approaches to explain the results of our AI algorithms that make it such that it is proof that the algorithm behaves properly. And that is, I think, lacking of any standardization today. There is nothing. There are a few research works, but there's nothing else.
Just a little teaser from me. Jean-Pierre
Yeah,
Houbeau, who just asked this question, will be in the afternoon panel discussion. We're really pleased to have you, JP, which will be dedicated to the solutions. And is the problem solved today? Is there something that we can already install and start using? And the only thing that is missing is the white paper that describes how to do it. So this afternoon panel session, Jean-Pierre Houbeau and others will be there. Please stay with us. JP, let me give a word to Thorsten and we'll come back to you. Is that okay?
Sure.
Thorsten.
I'd like to follow up on the idea of explainability, and we talked a lot about trust today, but typically when you do a scientific paper, it's not about trust. It's about reproducibility and allowing others to scrutinize what you have been doing. Now, the moment I use a federated privacy-preserving network, it's not like in the past where I am in control of my system and I know what I've done, but now I rely on this obscure network where something is done somewhere. I think this a bit undermines the whole idea of what a scientific reproducible study is, and I was wondering if you had any thoughts on how do you ensure reproducibility, that if you publish a paper or you file a patent, that you can actually prove in a way that somebody else can scrutinize it, what has been done, and that the results are valid.
Well, I guess even in a single partner setting, the reproducibility of machine learning training is not great because you need to control the tons of random seeds, initialization states, and that is already a problem. So that's, as an initial remarks. So what we try to do in Melody, and that's of course not a perfect solution to everything, is kind of that we take the same network architecture, that we take in principle the same algorithm sparse scheme, and we run that on single partner data, and we have also a public data set from Campbell, which everyone of the partner can have, and also the public has, and do in principle the same things on different data sets. And if the conclusions from pharma partners and Campbell do align, in principle that you see the same trends, then we hope that there is a certain level of trust. That's not the perfect solution, because that doesn't give you the result on the full federated architecture. Even then, of course, you can, on a public data set, simulate splits, right? You can artificially partition the public data set as it were individual partner. You can run the federated training. That's also how these kind of things get developed in Melody, by the way. So it is possible to do that, but of course not with exactly the same data.
Yeah, great point. Reproducibility. Yeah. How do we deal with that, Johan, and then Mark? Mark, then Johan.
I mean, I was going to say that yeah, it's a very good question, because we're not, as I said before, we're not really doing distributed learning, but I would argue that, by having the data sets in the same format and actually really knowing exactly what measurements we have and having standardized scripts that are doing the analysis actually helps with reproducibility. And the problem is just knowing how to backtrack and make sure there's not an error in the transformation of the data and stuff like that. So, and I think for the machine learning type of approach, I think this is something where it's the same in a federated setting or not. And yeah, that's what I wanted to say. Yeah, so please.
Yeah, so we've been dealing with this question several times as well, especially when the paper gets published, and the question is, how do we deal now with that, and how do we deal in this field? So in the beginning we said, okay, let's freeze a data set at all the data nodes, basically, and that they need to keep that archived, so that if we want to rerun it, that we can do it on a data set. But that basically means if everyone should do that, and then you have multiple researchers as well, that quickly blows up as well and grows. So then we were more thinking, what do we actually want to do? Do we want to have this reproducibility, that we can always go back to the exact same results? Or are we more interested that we can replicate the study, that the results might be a little bit different in terms of covariate weights of a model, because let's say there may be 10, 15, 20 patients added, but still the model gives, or the conclusions, what we had in the paper, still reflect what that new model gives. Because if you can do that and replicate it, that's maybe far more interesting than, and also if it doesn't replicate, it's far more interesting why that happens. Because if 10, 15 patients shift your model, then you have a different problem probably, right? So the question is, whether do we want to go for reproducibility and store all the data and keep that archived, or do we just have the methods to rerun it over and over again?
Great. Well, I promise to get back to JP, and then whoever wants to. Great. JP and a few more people. I think we'll start with you, and then the lady at the back.
Yeah, thanks. So there is, I think, one crucial issue that is related to the policy that is going to be deployed for this kind of operations. This is something that we've discussed extensively in the framework of the Global Alliance for Generics and Health, or the GA4GH, that might be familiar to some of you, where the vision is to be able to interconnect, organizations worldwide, each of them providing data and so on, and then federating the thing and so on. So the vision is powerful. At the same time, it requires to agree on a set of quality standards that are very demanding, and that will require scrutiny, vetting, and so on, in terms of data quality that is injected in the thing, and then whom do you allow to actually do this kind of operations? Who is allowed to perform queries on the system for how long? How do you make sure that the system is not gamed? Blah, 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 blah. So this is really boring, policy-oriented stuff. And I think there is no workaround, and there is no magic wand that will actually solve it by some crypto magic and so on. This is really something that one has to accept to go through it. and but it's worth it. But one should not underestimate the amount of effort that is involved and the amount of effort that is required to convince the lawyers and the policymakers at each of the institutions that the whole thing makes sense.
Agree.
Hello. Yes, Jules Fascal. I'm working at CHUV on the MEDCO project. I'm a developer on the MEDCO project. I have a question for David. You mentioned GDPR, and I want to come back just on the subtitle here, from theory to best practices. For now, you mentioned that GDPR is mostly about theory, and that you seem to be confident that in the next 5 to 10 years it's going to go into practice. But we saw that now most companies do not respect GDPR. What makes you think we're going in the good direction when we saw, like, on TV or it's public knowledge that in fact there are very small means and economic means that governments put to enforce GDPR respect from companies. Like we saw on French TV like 2 months ago that there are a lot of data breaches in health data that are not related to hacking, but mostly to companies simply not respecting GDPR. And we saw also that, the public institutions simply do not have the money to make it be respected.
That's a good statement indeed. You're right to say that there are no further incentives today for businesses to abide more to GDPR, technically speaking. But I think that businesses are more and more witnessing a value in abiding to being more GDPR compatible from a data subject standpoint, and offering new services, interfaces, new assistance to users in having their rights more applied or more transparently made possible in the various systems. So I think that businesses are becoming aware and conscious of opportunities around better abiding to GDPR with respect to the relationship with the data subject or individuals. The other thing is that technologies tend to become simpler and less costly and are embarked and become best practices. So naturally you have all of the IT providers that are improving over time their solutions in terms of encryption of communication, encryptions of storage, in terms of good practices, so not to store personal identifiers on disk, but rather pseudonymize and so on. So I think it's something that's taking time, but that's progressively coming in as a set of good practices, new technologies coming in that are less costly and that can be integrated more easily, and as opportunities with the relationship with data subjects.
Hey, I'm Karin from Roche, and I would love to hear this crowd's opinion about what role should big pharma play. Should we just be a consumer for basically doing real data studies and use the infrastructure? Should we help to grow something? Should we, what's your opinion from academia and small companies here?
Well, I think we would love to work together. I mean, I come from an academic setting, and I think that but I've worked in a company before and in pharma, and I know that there are different problems in the two settings, and often in academia we're not exposed to that, and we don't necessarily understand all of the issues, but by collaborating together, and I've had the opportunity to collaborate together with big pharma through public-private partnerships, and it's really beneficial to do that. But often I see that the the input from pharma is in a way limited because of the structure within pharma that has to regulate who, you know, where data can go, and this is a really I think an issue. But at least sharing ideas about technology and actually sharing development of technologies, and not just the costs, not using the companies as for investing funds, but really to work together on the problems, because I think there are brilliant people in companies as there are in academic institutions, and it's only by working together on common goals. Because I think we do have common goals. I think that's what I would like to see more of in the future. Yep.
Ansgar, what do you think about the role of pharma, both in the world of assay data and compounds, but also when it comes to patient data?
Well, I think there is obviously quite a lot of domain expertise in the pharma. And I think as we now, some people say, live in the area of data-centric AI, that domain expertise is kind of important for making good use of the data. So I think it is kind of really in the ideal setup is a collaboration between academia, partners, startups also, right, to build this thing together. I think you cannot just sit back and say, I'm here a consumer, I wait until there is something to buy, because if we in Melody, as all the pharma partner had did that, we would have nothing, right? It's not the way that how this can work. But on the other hand, we can also not say yes, somebody builds that outside and then comes to us without having us the opportunity to give some intellectual input, so that the thing really does also what we are interested in, and so the collaboration is the only way to go.
Great. And I just deviate from pharma to the society and back to pharma to Cedric in a moment. How do you think the society sees this, the general public? We are developing some fantastic technologies and machine learning, concerned about preserving people's privacy, their privacy. But what do you think is it for them in it? Do they understand? Do they care? Do they see the advantages? Who would start? David here.
I think that most of the people, I mean, are not educated about privacy, and I think that what we just have, the most important, one of the important steps we just made during the COVID crisis is to understand the notion of sovereignty. The governments, which were as poorly educated as most of the people about data privacy, discovered the important notion behind data sovereignty during the COVID crisis, and so this has been, I think, one of the first important steps to recognize the fact that countries, and I would say even regionalities, I mean, all territories of a certain critical size need to think about a sovereign data strategy, because data has to be kept in secure local places where people have an access, where you have control, and where others from the outside potentially cannot hack into your data. That's one of the first things, and I think that COVID has been, unfortunately, good for one thing for this. The second is, I don't think that people understand really anything when they use internet, the risks of sharing their data, of browsing through contents, of accessing certain contents over the for instance, the social networks. So I think we still are far from a population that is sufficiently well educated about data sensitivity, about data profiling. And so I'm afraid to say that today we are not really, we have made very good advances technologically speaking in protecting data, in finding out new technologies to ensure traceability, to have almost, I think that we are not too far from shaping up actually the European health data space that the European Commission is trying to develop by 2025, because we have all the technologies to protect the data, at least to protect the data from this very moment in time according to the threats that we know. And we have the technologies to ensure the traceability and to make this thing happen. But at the same time, people do not yet understand what the data, what is the value behind the data. I can give you an example. For instance, in France, so during the COVID crisis, another important step we made, I think, at least in France, is to move forward in defining what standards to go for, in defining a referential, a framework into which all of the health professionals will have to abide and inscribe and fit into, so that they can, in the future, offer their services. So France has moved terribly fast during the COVID crisis in putting up this framework and a strategy. We have now a strategy where we have defined electronic identities at the national level for accessing all of the health services. We have defined and formalized the health space, and data space, for citizens to access their data, but also a number of health services. And we have shaped up the health data hub, which is a voluntary approach from all of the data controllers in France to have the data from citizens, medical data from citizens, shared in a central location for research and only research. This has been moving very fast. But at the same time, we are led by people that are terribly lacking of education about data privacy, sovereignty, and so on. So the first contract we signed for hosting the data was with Microsoft. And so it became public after a couple of months. It made a scandal, and then the government had to go back and reopen the call for tender and have basically French public cloud providers apply. So, but that decision was made by a minister. So our ministers, they don't even understand sovereignty, which is the basics, the absolute basics. That's a very fundamental building block. Then comes privacy. So this is to let you understand where we are.
Yeah, great, thank you. Mark, just a couple of words, and then we have a question.
Just really a couple of words on that. I mean, I think that privacy is really, education is really important in this, and also, as well as the regulation. But what I wanted to say was that, coming back to Marcel's presentation this morning, I really loved the slide where he showed the trust in different applications and the fact that people are using a lot of applications they don't trust. Why are they doing that? I would say they do it because they're getting something from it. They're getting a lot from Facebook, and it outweighs the risk that they perceive. And maybe that's wrong, maybe that's right. But I think we need to think about, if we're offering something or we want people to use something, we have to give the carrot. And so
that's right. Okay, please, Cedric, a question from you.
Yeah. Cedric, European citizen. It's not relevant for whom I'm working for this question. Somebody who is about to die has nothing to hide. So to me, the question is not about not sharing. People will share if it's a question of life and death. The question is more to whom I am sharing this information. And it used to be a physician, a human person. And now the problem is that it's a machine or many machines. And when I mean machine, I mean hardware and software. So it's a question of trust. I used to trust a physician. That's why I shared. Now, how can I trust this machine, hardware, software? We don't trust the technology provider because of liberalism. We know that they are profit-oriented like any company, so there is a question of trust. We don't trust governments because they are inefficient, and we all know that the border between companies and government is more and more blurry, especially in the very liberal cultures. So my question to the panel is, do you see a new type of actor that can emerge, that people can trust to handle their data? And what would be the approach that these actors use in terms of technology, hardware, and software, especially with regard to transparency? I'm not saying transparency of the data itself, health data itself, but more the transparency about what is done to this data, by whom, where, and to what purpose.
Well, building trust, I think, has many different factors in them. Transparency is, of course, one of them. But I think it's not the only solution to get trust in that sense. Because if you want to be transparent on what, for example, a certain analysis or algorithm does, then the question is, do people understand what it did actually, right? And why that data was needed. Compared to what you now have, these, what was in the Android App Store, these labels on privacy. For example, it says, I need your Bluetooth location. Why is it asking that, right? The explanation of it, and definitely knowing that people understand that they make a conscious decision on that, that's still, I think, the major obstacle in there. So that's also why I think the problem of getting a society convinced what works and those aspects is a hard thing to reach, and therefore also to reach trust, because you can be as transparent as possible also on the machine learning algorithms that you're going to send around and explaining why it's privacy preserving and these kind of things. The question is, do people fully understand it, or if they just take a few buzzwords and go running with that, it becomes completely out of context, and then the question is, did they understand what we're doing here? Maybe not, but they're now, or declining, what you want to achieve. If you then look what we have as a current situation, well, if you look at the National Statistics Agency, if you see what data they have and the amount of data and the information on people, well, I know that they're making high-level information now public, at least from which variables do they collect, but not on the individual person level, because I think they're also looking like, what kind of backlash are we getting then? So it's something we need to work on, but we should be careful how we approach and how we address and how we want to tackle that one. Yeah.
Maybe, I mean, I like this idea. I mean, we go to a physician, we go to different specialists for different ailments, and why don't we go to a data doctor? I mean, this is something that's important for us. I mean, that could be something that could happen in the future. You know, who is managing that for you? You know, you go to an insurance company to make sure you're okay in terms of if something happens to you. What happens if something happens to your data, and how to best use your data? So yeah.
Great. Lunch is just a few minutes away. I see there are still a couple of questions in the audience, which is fantastic. But to make it clear to all of you that we will provide lunch free of charge, there are no costs involved, unlike in the Biodata World Congress, just in the next room at the Singapore. So make sure that you have enough fuel for the afternoon session as well. But now I move to the next question.
Thank you. So again, Daniela from Freiburg, and I have also a kind of question to trust, and maybe mostly to Johan and also a little bit to Ansgar. I'm a statistician, and I have the problem that I need to convince the data protection officers at the single sites that the algorithm, as I implemented it, is working as I intended, and also that the values that I do exchange are privacy preserving. So for example, also a covariance matrix as such. And I mean, there are some mathematical values like differential privacy values, but we do not know how to interpret those values. So how was your experience with convincing them that this algorithm, for example, in this lung cancer example, that it was really usable?
Similar. No, short answer, similar. And I think that's one of the things, a more standardization on, let's say, governance about how these federated analytics work and how you implement them, and also maybe have someone who check that, and that people understand, like privacy officers, like, okay, if they follow this whole protocol and procedure, then we're willing to accept it, and that they get also a more homogeneous understanding about that. I think that's one of the things we need to achieve at the moment, because indeed it's bashing against the door in every hospital, and as soon as if there's a new privacy officer, then you can start from scratch again. So I think that's one of the major hurdles at the moment. Yeah.
Yeah, I think there is not so much to add here, but in the end, it is also the question, kind of, if you're not dealing with privacy, but with IP, this question is similar. Of course, the question is, what is the risk, right? And you can only try to address this with the risk analysis. So what are we actually concretely afraid of? What are the things which we really want to prevent? And then you can try to go into these details. And of course, if you do a federated machine learning, you do share information in one or the other way. So it is not that there is no information transferred, but you can, for instance, with the compound space, to ask the question kind of, so how likely would it be that I can know that concretely company X has a compound of type Y from that model? Can I quantify that? And then probably the answer is, yeah, you can maybe quantify that with an attack model to some degree of certainty, or then you can deduce, oh, yeah, the uncertainty is so low that that is practically useless and nobody would have learned anything. And in our case, we have really a specialist on the consortium from the young BME in Budapest who tries really to do reverse engineering attacks along the lines where we think we are afraid of.
I mean, maybe a comment on this as well. We've had similar problems or issues coming up, and it seems like the data that each, cohort, let's say, or each institution has their own rules of what they consider to be, if something's a mean of 5 or less individuals, it might be okay for one institution, but not okay for another one. And then, ranks might be considered, to be okay for some institutions, but not for others. So, but I think that the only thing that we tried to do is to be as transparent as possible and actually to give examples to show on their data what this would mean. We also had, issues like, if we're trying to do some sort of data integration technology where we have to transfer data between different nodes, we're transferring matrices and the transformed matrices, and so we come up with, there's someone in our group who's working on the maths behind that and saying, okay, and he says basically, okay, well, if you hacked the system at this point, this point, this point, and this point, then you could potentially get back to the patient data. But is that enough or not? I mean, is that secure enough or not? What is the risk of that? You can't really quantify it, but you can say it's very low. Yeah. So.
Last question here from Judith, and then we're up.
Yes, hi, my name is Judith Kischblind. I work for a large hospital in Switzerland as a lawyer. I'm not a privacy officer, anyhow. I just wanted to say it's really a question of understanding. And we lawyers don't really understand the scientific backgrounds, but you have to explain to us what kind of data you want to use to transfer what you want to do with it. And it's just a question of explanation, and I think that goes into that what Mark said earlier also about every lawyer having his own interpretation about GDPR. It's more about understanding what data you are talking about. And please explain it as you would explain it to your 5-year-old daughter.
Thank you very much, Judith. This is a point from a lawyer here. So we have one. We discussed them in the morning, and it's really nice that you brought it up. Fantastic. Any thoughts while I'm on my way back?
Well, my daughter is 1.5, so I think I'm going to have a bit of a problem there. But yeah, it's a really good point. I think that we need to make a bigger effort to explain this, and some things that seem obvious to us because we're working in science, that we need to make the effort. Yeah, I completely agree.
Maybe interesting to have a discussion over lunch, but to see how we can transfer them from lawyer to lawyer, right? Because we're now also as researchers doing it every time for every hospital over again, right? So how can we share that experience to make that process maybe also easier? But yeah, happy to discuss.
Fantastic. So let's start wrapping up. We don't want to be between you and lunch at the moment. Just the last thing from you. Having heard the discussion and knowing the topic and having your expertise, how would you, if you were tweeting, how would you hashtag the key message of today from you? Johan, if you are sending a tweet now, what would you put as a hashtag?
To be honest, no clue. Not sure if anyone else has
David?
an idea.
Hashtag lunch. That's a good one. Ansgar, anything on your mind? What do you think would be the key message? Short one.
I think in the end we have talked a lot about trust and kind of how to build trust. That might be the thing, and this can be done in different ways.
Hashtag trust.
Can it be a long one?
Yeah.
Federated learning is not technical.
Federated learning is not about the technology, right? It's not technical. Great one. And Mark?
Well, trust is important, but I would say communication. So communication about how we're doing things and transparency. Yeah.
Hashtag communication. Fantastic. Well, thank you very much, all of you, and a big round of applause to our panel.